Hey there, rock stars. Welcome to another awesome video about math today. And I want to welcome you as my mathematicians ready to rock and roll. Today we're going to talk about ratio foundations. Basically, an intro to ratios. Do you understand ratios? Do you know what they are? Well, that's what we're going to figure out. Do you know what weighs as much, or I'm sorry, what is as big as an elephant, but weighs 0 pounds? The elephant's shadow. Yep. That would be one weightless shadow, but a huge shadow because elephants are large. All right. So, like I said, today we're going to learn to represent a relationship between two quantities or values. Okay. So, you're going to use these things called ratios. We're going to use those formats that you see right there. We're going to be using A plus B, or I'm sorry, A colon B, A over B. You're going to say A to B, all kinds of different ways. I'll explain it later. We're going to be talking about part to part. We're going to be talking about part to whole. We're going to be talking whole to whole. And then we're going to create a relationship in words when we're given a ratio. Okay. All of that may sound confusing. That's because you don't know it yet. I'm about to teach it. All right. So, vocabulary time. Ratio. All right, so this is the comparison, okay? So that's an important part to underline. Comparison of two values of the same kind, which may be written as, again, we talked about that, A to B, which down here, for example, here's two values, 4 to 6. A colon B, which is written as said, 4 to 6, or as a fraction A to B, which is 4 to 6. And this one I just used the numbers, and this one I used the words. So 4 to 6, 4 to 6, 4 to 6, and 4 to 6. They all say the same thing, they're just written different ways. Okay, so let's talk ratios. We're going to talk about ratios in one quantity right now. What I mean by that is we have a collection of things in one group. Okay, later in this video, we're going to get to two groups. Right now, we're talking about one group. Okay, so remember, ratios are a comparison of any two values. Okay, so let's look at this. Let's use an example because I think that's going to help you understand a little better. Okay, here we got some balloon animals. Okay, but we got different colored balloon animals. So we have some red balloon animals, we have some green balloon animals, and we have a collection of all the balloon animals. So in this scenario, that the ratio wants to know what is the ratio of red to green balloon animals. So we simply got to count our red balloon animals, and we see 3, and we count our green balloon animals, and we see 2. And remember, there's a bunch of different ways we can write it. We can say 3 to 2 like this. We can use the numbers. We can use the colon, which says 3 to 2. And we can use it as a fraction, 3 to 2. Now, whenever you see a fraction like that, it also means this, okay? This is just a way on keyboards when you hit that slash button, it means fraction as well, but that's kind of what we're dealing with. The other thing I need you to make sure you understand is you have to put the ratio in the same order as the way it's asked. So you have to do red to green. So in that case, we did 3 red. That's why the 3 is first in all of these. Okay, and then you have to do 2 green, and that's why the 2 is last in all of those. Okay, let's try another one. Okay, so remember, it's a comparison of two values. Here's our same collection of balloon animals. So for every 3 red balloon animals, there are 2 green balloon animals. When we have two quantities, all right, so we have two different quantities. We have 3 reds and we have 2 greens. When we have 2 of them, we have 2 different ways to look at them. We can look at them as parts and wholes, okay? This scenario is part to part. Why? Because the green blue animals are part of the whole collection. The red balloon animals are part of the whole collection. What would the whole collection be? Well, it would be all of them. It would just be 5 balloon animals, right? So you can kind of begin to understand when we say the whole, we're talking about what do I have all together? And the part is when we break them into 2 different values. Well, what are the reds? Well, there's 3 of them. What are the greens? Well, there's 2 of them. Those are both part to part. So I highlighted this in your notes so you could see part to part. Red, there are 3 red, which is part of the whole, and green is part of the whole. Okay, let's try another one. Same balloon animals. What is the ratio of green to red balloon animals? Didn't we just answer that? Yes, but in a different order. And in this case, we're going to say there are 2 green balloon animals and there are 3 red balloon animals. So this time it gets reversed because the question was reversed, okay? So there's 4 different ways you can show it. Use it in words, but using the word 2 in between, or use a colon or use a fraction. So for every 2 green balloon animals, there are 3 red balloon animals. You starting to see that ratio, how that works? Okay, and again, red to green is still comparing part to part because green is part of the whole and red is part of the whole. All right, so let's do this again. What? Same balloon animals. So let's see what we're talking about now. What is the ratio of balloon animals to red balloon animals? Well, this one doesn't specify do we want the red or green. It just wants the balloon animals. And how many are there? There are 5. How many red ones are there? There are 3. So what's our ratio? For every 5 balloon animals, there are 3 red balloon animals. And that's how all your different ways you could show that as a ratio. Now, the reason I did this one is because I want to show you now we are comparing whole to part when we're dealing with our ratio. We compared all of them, that's the whole group, to part of them, which was the red ones only. Okay, so all the balloon animals is the whole, and red is the part of the whole. Okay, let's try another one. What? Now we're doing what is the ratio of green balloon animals to balloon animals? I think you're starting to catch on here. We're just really looking at how do we compare these numbers using part to part, whole to part, or part to whole. Now this one, we do green animals first, so there are 2 of them, and we're comparing them to all the animals. So 5. So our comparison is 2 to 5. Okay? And there's the 4 different ways you can write it. But again, what are we comparing? This time we went part to whole. The green animals are part of the whole, and all the blue animals is actually the whole. All right, so now here's a different scenario to look at. Now we're going to have 2 different quantities, so 2 different groups. We're still going to have our balloon animals, but there's this whole other thing that we're going to compare that to, which is these, let's call them lizards or geckos or whatever you want to call them. I'll call them lizards. All right, and so our question is compare the number of green balloon animals in quantity A to the number of purple lizards in quantity B. All right, so how many green balloon animals do we see? We see 2. How many purple lizards do we see? We see 1. So it's 2 to 1, or 2 to 1, or 2 to 1, or 2 to 1. But this scenario is part to part. Why? Because it's part to part between 2 different quantities. So green is part of the whole of quantity A, and purple is part of the whole for quantity B. Part to part. Next up, we got the same scenario here. We got all these guys again, and we're going to compare the number of balloon animals in quantity A to the number of lizards in quantity B. Well, this one doesn't say which ones, it says all of them. And this one doesn't say which color, it says all of them. So now we are comparing 5 balloon animals to 6 lizards, 5 to 6. And since we use this whole group, that's a whole. And since we use this whole group, that's a whole. So this one is a comparison of whole to whole. Okay, now what if I give you a ratio and you have to come up with a scenario for it? So everything you've seen so far is I've drawn some pictures for you and then I've said, tell me what the ratio is. Well, this time I'm going to give you a ratio, 7 to 3. All right, so 7 to 3, you can look at it and say, well, I shot 10 baskets, so that's the whole group. All right, and that's the reason why I said that. I shot 10 baskets. How do I know that? Because these are going to be equal to 3, or to 10. I made 7, and I missed 3. So this scenario would be, what is the ratio of your made baskets to your missed baskets? And that would be 7 to 3. Anyone want to guess what that is as far as part to whole, whole to part? Well, what would the whole be in this scenario? The whole would be 10 baskets. This would be part of them he made and part of them he missed. So that one would have been part to part. Now, let's look at this scenario I created. For my birthday, I got 8 birthday cards. And my twin brother got 13 presents. So now we got, remember in those other examples we had 2 quantities? Well, here's a quantity altogether of 8, right? So here's a quantity of 8. So I had 8 birthday cards, and my twin brother got 13 presents. So we got these 2 groups. We got 8, and we got another group, we got 13, right? So of the 8 cards, of my 8 cards, 2 of them played music. And of my brother's presents, 7 of these were close. So my scenario here is 2 to 7. 2 cards that play music to 7 gifts that were close. All right, and that would be part to part as well because we're talking about part of this group and we're talking about part. So this is 2 parts, part of the 8, and this is 7, which is part of the 13, part to part. All right, guys, some ratio basics. Let's fill in the blanks. Ratios are a comparison of any two values. Okay? So a ratio is used to represent relationships within and between. Within what? One quantity, and sometimes between two quantities, like the lizards and the balloon animals, or the gifts and the cards. Okay, so ratios can be written using a bunch of different ways. We can use a colon, 3 to 4. We can use put it in words, 3 to 4. We can use the numbers but put 2 in between, 3 to 4. Or we can use it as a fraction, 3 to 4. And then finally, ratios compare what? Part to part, part to whole to part, or whole to whole. We didn't really, and we did go over a whole to whole in the gecko or the lizards situation. All right, I think you guys got a good foundation of understanding ratios. So I think you guys are super positive about this, but I think horses are negative. And why do I think horses are negative? Because all they do is walk around and say nay to everything. Nay!